So, hello and welcome to this short additional video to the 2D series. In this video, we will be covering how to add smooth camera following to your character controller so that your characters will be followed by the camera without it flipping around or looking weird when the camera changes direction or jumps. And it will allow a greater overview and will make it look more natural than instantly jumping to the character's position. So right now, in my game, I have this main camera that looks at my scene, and I have my character. And if I hit play, you'll see that my camera doesn't move. It sits still. And I am actually going to mute the audio sources in this scene so that it is not as loud. And you can see here that our character moves, jumps around, my camera staying still. In your game, you might have a slightly smaller camera, like this, that is sitting on top of your character, and then your camera is parented to your character, like that. And now as you move, your camera follows your character like this, and jumps. And this is very instant. If you flip, you see this sudden jump as it flips back and forth, and it doesn't look very good. So I'm going to show you how to make a camera that follows the player very smoothly. So the first thing we want to do is, if your camera is inside your character, you want to drag it and take it out of your character. You can do that by just dropping it down below. You have your camera here, and now your game will run, and your character will be able to move around, but your camera won't go anywhere. And we have that. And now we're going to want to go into whatever our scripts folder is. We're going to make a new C# script. And we're going to call it smooth camera follow, or camera follow, or whatever you want. You can't call it camera or else Unity will break, so I like to call it what it is, a smooth camera follow. And then you can open that up in either MonoDevelop or Visual Studio. Here we have it in MonoDevelop. So we're going to make a few variables at the top here. The first one we're going to do is going to be a float, and it's going to be interp velocity. And what this will do is this will be the interpreted velocity. So the velocity the camera should be going to keep itself following smooth with the player. We are going to want to add a public float called min distance. This will be the minimum distance between the camera and the player. So if you want the camera to always be slightly behind the player or slightly in front of the player, you can change this around. We have our public float follow distance. So this is how far away should the camera follow. So if the player moves, how long will it be till the camera starts catching up with the player again. We want to have a public game object that is our target, so the target of our camera. So you'll be able to put the script on any camera you want to follow anything. In this case, our target's always going to be our player. Then we want a public vector3 called offset, and this is how far off you want the camera to be. So if you want the camera to be centered higher than the character, lower than the camera, to the left or the right of the character, you can change the offset. And this will show up as an XYZ thing that I'll show you later. So now that we have this, we also need a vector3 that is the target position. And this is just where we're going to store the target's location. So now that we have all that, we can go into our start. I'm just going to clear up some of this white space in our start. Inside our start, we're just going to want to take the target dot we want the target pose to be equal to the transform dot position. So this is going to mean that when it starts off, set the camera equal to the or set the target position equal to the center of the camera, so then we can adjust this to move the camera to jump to our player. And that is all we need in our start. So now we have update, and if you remember from really early on in the series when we did some physics stuff, there's different kinds of updates. Right now we want a fixed update, so you can just add the word fixed in front of update. And this means that this will run at a consistent rate. So even if the frame rate isn't happening, this will constantly run. And that's good for a camera, because you don't want a camera to sit and not do anything between frames, because then it will look like it jumps between each frame. You want it to be moving even if there isn't a frame loading, so it smooths itself out. So inside our fixed update, we want to first check if there is a target to look at. Because if there isn't a target, then we shouldn't try to find the target. You don't want to cause an issue with your game where it tries to do something if there isn't anything there. Then once we have the target, we want to do a vector3 called pose no z transform.position, just like that. Then we want to set pose no z.z to be equal to transform.position.z. Or no, pose no z is equal to target.transform.position.z. So what this will do is it will keep the camera at the same plane at which our player is, so our player is always in view. Then we want to have a new vector3, and this will be our target direction, and this is equal to the target.transform.position minus pose no z. So this is the direction we want our camera to be traveling in. So get the target's position, get where our current position is. So this is pose no z, this is our current camera position, and find where this has to go by subtracting the two and getting the difference. And once we have that, we can say our interp velocity is equal to the target direction dot magnitude times, in this I'm just going to use 5f as a good scaling factor. And what this will do is it will say our velocity should be equal to this. So earlier this is finding the difference between where we are and where we need to be. So by the magnitude, we'll return that scale, and then we're going to scale it up by 5 just so it's big up and our camera will continue to follow the player. You can change this, and this will change how fast your camera moves around. Now quickly it should get to its destination. Then we want to set the target pose equal to the transform.position, so the position of our camera, plus the target direction dot normalized. So this will convert the entire scale, however big it is, to a value between 0 and 1. We're going to multiply that by our interp velocity, and then we're going to multiply that by time.delta time. So time.delta time is the difference in time since you started running something. So this will be like if you start at 0 and then you get this will be the difference between 0 and this. So 0 and 5 will return a value of 4 as the difference in time that's passed. And then once we have that, we can just set our transform.position, so our camera's position, equal to a vector3.lerp. So I went over what lerp is with a few people in our classes, but lerp allows you to balance a object between two locations, so it will create a smooth thing where it will have a destination in mind, and it will just fractionalize how far it needs to travel, so it looks smooth even though it's going by set numbers. So vector3.lerp, and we want to lerp between the transform.position, so where we currently are, the target position, so target position, plus our offset, which we had at the top, and then you have to say the time length at which it should alert between it, and we're going to say this is 1/4 of a second, and you can change this to whatever you want, and that will change how fast you're jumping around. I'd recommend keeping it around this. So this is our entire script, and what this will do is, I'll just run through it one more time. We set up all our variables here that allows us to change how fast it's moving, where it's moving to, what our target is. We set the target position equal to the to our current position at the start, and then we update through if there's a target to change our position of the camera to our target position. So if you save this and go back into Unity, then on your main camera, here we go, you can drag the smooth camera onto your main camera. In here you have some numbers here. You can leave all of these at 0, and then target, you can just drag and drop your character into target. Oops. Character into target. And this will just follow the character pretty closely without anything special. And if we run the scene, you'll see our camera follows our player. And it does it in a smooth fashion. And you can change the magnitude scale and the time scale to make it get closer or farther away. So that's all you need for a smooth camera. In the next video, we'll be making a little menu, and then once we have the menu, we'll be jumping into 3D games.